This next video is going to be how to multiply radicals together that have some negatives underneath. We've talked about simplifying them. Now we're going to see what happens when I have a product of these things. Now we're pretty used to the product property for radicals, that if you have a radical times a radical, it's the same as if you just do the radical of the product. Now the thing about this definition and this property is that it's really only true for all positive values of a and b. So it's just a little different when you have the square root of negatives, which we know is an imaginary number. The square root of a negative doesn't exist in our real number system. It's defined to be an imaginary number. So we're going to go through these 4 examples and see exactly, okay, how do I deal with that? And basically make the problem okay to use this product property. So what you need to realize is that this is not equal to the square root of positive 50. You might want to do a negative times a negative is a positive, but they're just not equivalent. And the whole reason is that the square root of negative 10 is I root 10. And the square root of, you know what, I'm going to do that in a different color. Let's do all our work in blue. This is I root 10, and this is I root 5. Really sounds like an interstate highway. Oh, I wrote 50. I root 5. And then I can go from here. I can multiply, because like this is all being multiplied. The order doesn't matter. There's no grouping. So this is really I times root 10 times root 5, and realize you can just put together what you can. So this is I squared times root 50, which we know I squared, and put it up over here, is always negative 1. So this is really negative 1. Root 50 will simplify with 25 and 2. So this is really negative 5 root 2. So you end up with a negative result. So if you had made the mistake in the beginning and said that this was equivalent to root 50, you would get the answer wrong, because you would have just simplified this to 5 root 2, which is not correct, because the answer is negative 5 root 2. So in general, your process is, if you have the square root of a negative, make sure you kind of simplify that first and take out the I, like turn that square root of a negative 1 into an I, and then do your normal radical simplification. So let's do that for example 2. So instead of 2, the square root of negative 3, we'll write this as 2I root 3, and this as 7I root 18. So now I can multiply the kind of coefficient parts together. So this is going to become 14I squared. And then 3 times 18, I can actually use that product property because they're both positive now. So this 14 times I squared is negative 1. So this is negative 14. And this is going to be, 54, square root of 54. But I can already see that that's the same as 9 times 6. So it's going to be root 9, root 6. So this is negative 14 times 3 root 6. So negative 30 plus 12, 42 root 6 is my final answer. Okay, let's keep going, just to see all the different types that we might come upon. All right, next one. This, I guess I'll deal with these coefficients first. There's always multiple ways to do these, but I'm going to multiply that negative and that 2 together and just get negative 2. I'll show my steps. Okay, so now before I multiply this root negative 2 and root 8 together, because they need to be positive, I'm going to rewrite root negative 2. So this part right here I root 2. But then this negative 2 is still there, and this root 8 is still here. So what we have is negative 2I. I'll multiply these together and get root 16. And a perfect square appears, which is great. And I know that the square root of 16 is just 4. Not root 4, right? The square root of 16 is 4. So then I can multiply this together and get my answer of negative 8I. So this one ended up being different than the other ones where my result is imaginary. And if you look at the pattern, that's going to be because I only had one negative here. Well, in example 2 and 1, I had 2 negatives, which when you had I times I became I squared, and you got negative 1. Where in this case, it's staying imaginary because there was only 1. That's probably going to happen in the next one as well because I only see 1 negative. But we're still going to go ahead and simplify. So this is the same thing as I root 3 times root 14. So all I can really do is multiply 3 and 14 together. Even if I wanted to simplify first, I really can't. There's no perfect squares that go into 14. 42. Okay, so I'm debating over here. Can 42 really not be broken down? It's 2 and 21. Okay, so its only factors are 2, 3, and 7, so there's no perfect squares in there. Seems like such a nice divisible number that we could simplify it, but we can't. So you're just going to leave it like that, I root 42. So in summary, make sure before you multiply like you used to simplify, you write it, like if it's the square root of a negative radical, you write it as I times that radical. And we could even make that kind of a general rule. Maybe let's end on that. Oop. So I'm going to move this over here. And this over here. And just in general, what you're going to do is if you have the square root of a negative times the square root of a negative, I don't love this rule. I would just go through the process, but it ends up being that. All because of what we talked about the other day, that this is the same thing as I root A. Remember, to get there, it's all because it's the square root of negative 1 times the square root of A. And the square root of negative 1 is I. Right? This is I. Alrighty.